Have you ever finished a tin of Altoids and thought, that's a nice looking tin? Many people have. Over the years, Altoid tins have been repurposed for a wide range of things, from sewing kits and survival kits to handheld gaming systems and audio amps. But have you ever looked at a tin of Altoids and thought, that looks like a tiny computer? It is common in the Cyberdeck community to use robust containers like pelican cases and ammo boxes to make cool-looking Cyberdecks. Altoid tins tick a lot of boxes here. They are robust enclosures, nondescript, and DIY friendly. If maybe a tad small. So I wanted to take an Altoids tin and make it into a fully fledged Cyberdeck. With a mechanical keyboard, display, and some external inputs and outputs. But I had to figure out how to fit all of that inside an Altoids tin. For the CPU, I would use a Raspberry Pi Zero. I bought these used a few years ago, so the first thing I did was make sure they work. I also had this old 2-inch LCD that I didn't use for another project. Getting the LCD to work took a little bit longer than expected, as it uses an SPI interface and I had to use a legacy version of the Raspberry Pi OS, as well as make some changes to the Raspberry Pi config. I wanted my Cyberdeck to be self-powered, so I ordered a UPS. I wanted to build this keyboard myself, but I had no idea how to construct a keyboard. So I purchased this pocket type kit from Mechboards. This was a really fun little project, and I got to learn how diode matrix keyboards work. A diode matrix is a grid of buttons connected in rows and columns, with diodes for each button. The diodes generally sit between the button and the row. By connecting each row and each column to an input on the microcontroller, you can easily distinguish when a particular button is pressed. This means that you can use many more buttons than your controller has inputs. Building the pocket type was the perfect segue for thinking about how to build an even smaller keyboard. Because at the end of the day, this keyboard was going to have to be pretty tiny to fit inside the Altoids tin. So I soldered together a little test PCB with 4 buttons and a simple diode matrix. I bought an RP2040 to use as the microcontroller, and I decided to use KMK for the keyboard firmware. KMK is a beginner-friendly firmware powered by Python, which makes it simple to program the diode matrix. Then it was time to build something sized perfectly for the Altoids tin. I built the entire thing on a cheap proto board. Maybe next time I'll have to teach myself PCB design. But in all honesty, this is a really enjoyable part of the project, and I was very satisfied with how the keyboard turned out. Once I had it assembled, I programmed it with KMK and checked that it worked. The exact key map I will include on my GitHub or on hackaday.io. Even though I now had a nice little keyboard, it was still going to be a real trick getting it all to fit inside the Altoids container. To make things a little bit easier, I purchased a smaller battery. This gave just a little bit extra room. I also slimmed things down by removing some of the components and soldering the UPS board and the display connector directly to the Raspberry Pi. However, there were even more features I wanted to add, like a 15-pin breakout for some of the Raspberry Pi's GPIO pins, and a USB hub so I could connect both the keyboard and have an external USB port. To hold all of this inside the Altoids container, I went through a lot of design iterations. In the end, I went with a flexible 3D printed frame that bent so I could fit it inside the Altoids tin. The frame was then locked in place when the front panel was installed. I also added a thermal pad so that the Raspberry Pi could dissipate heat out the back of the tin. Getting everything in there was a real game of Tetris. And despite everything I'd done, it didn't quite fit. I still went ahead with sizing the cable for the keyboard, and with a little bit of super glue and baking soda, I added some nuts to mount the keyboard to the Altoids tin lid. In the end, in order to make things fit, I ended up removing the connector on the display and soldering the wires directly to the LCD board. This freed up just enough room to get the front panel on. There still wasn't quite enough room to shut the tin, so I used some pieces from another Altoids tin and soldered them in place to extend the hinges. This gave just enough room to shut the tin. Then it was on to some finishing touches. On the side of the tin, I engraved labels for the GPIO pins, as well as labels for the charging port and the USB port. I had a little bit of paint left over from my Tommy B build, so I painted the faceplate beige, like a vintage desktop. After I extended the hinges, it meant the tin no longer stayed closed. So I bent the lip of the tin just a little bit, which provided enough friction for the tin to snap shut. With that, the Cyberdeck was done. It looked perfect. And with the GPIO breakout, it should be able to be used for some light prototyping and maybe some other fun little projects. Here, I used the Pi GPIO command line tool to move a servo, which was kind of fun. I really enjoyed getting to make this teeny tiny Cyberdeck inside an Altoid container. I hope you enjoyed the video. And I just wanted to thank everyone who subscribed to the channel so far. As of making this video, I have just over 5,000 subscribers. I haven't been able to post project videos super consistently. At this point, I'm maybe averaging one a year, but I'd like to do better. So I'm now offering memberships for the Exercising Ingenuity channel. There are 2 levels of membership, the Idea Idlers and the Ingenuity Engine. But both levels of membership go towards keeping me working on projects and help me share them with you. So if you become a member, the more members that join, the more member-specific perks and content I can offer. So please look into becoming a member. Otherwise, please subscribe, and I'll see you on the next video.